to great scientists. Tonight I'm going to be talking about the life and career of the legendary Sir Isaac Newton.
Newton was born into a world on the brink of a scientific revolution. And although scientists had made a number of interesting new discoveries, they still didn't understand what basic physical forces held the universe together.
The solution to that problem would immortalize the name of Sir Isaac Newton.
Isaac Newton was a brilliant mathematician, a biblical scholar, an astronomer, and an inventor. But his greatest contribution to science was his discovery of a set of universal laws to describe the cosmos.
Cambridge University is justifiably proud of its illustrious old boy. But when he studied here, science was very different from what it is today.
In Newton's time, the study of the physical world was known as natural philosophy. But Newton's pioneering work would lead him to be seen as the father of modern physics.
In middle age, Newton became a difficult and a rather disturbed man. But perhaps the seeds were sown in early life.
Isaac Newton was born on Christmas Day, 1642. A tiny and weak child, he seemed unlikely to live. His mother left to marry a 63-year-old clergyman. Brought up by his grandparents, Newton grew up a lonely and unpopular child, often fighting and causing trouble. As a young man, he was obsessed with inventing and building things. He was particularly fond of making sundials, which were his preferred method of telling the time. At the age of 17, he was brought home from school to manage the Woolsthorpe estate, but he was rubbish at it. Fortunately, his headmaster recognized his talents, and Newton prepared for university life by buying some simple necessities: ink, candles, a notebook, and a chamber pot. And so it was that he set off for Cambridge. However, on arriving at the university, he soon had a religious crisis and made a long list of his sins, including baking cakes on a Sunday and sneaking a piece of cherry pie.
Bloody hell. Wasn't that terrific? Isaac Newton came up here to Trinity College, Cambridge as an undergraduate in 1660, where he found, surprisingly, that the curriculum was still dominated in the sciences by ancient philosophers such as Aristotle.
Many academics at the university were still teaching ideas that had originated over 2,000 years previously in ancient Greece. And despite the work of scientists such as Galileo, many of these ideas had never been subject to scientific scrutiny. There were, however, a number of Newton's contemporaries who were starting to conduct experiments to test these ideas. And these men were to encourage Newton's own rigorous approach.
Isaac Newton was influenced and inspired by many of the men of his age, though he rarely ever gave them much acknowledgement. But perhaps the most influential of all of these figures was Dr. Robert Hooke.
Here, at Wadham College, Oxford, Robert Hooke worked with a group of men who would later become the Royal Society. The Royal Society, of which Newton would eventually become president, played an important part in spreading information to the middle classes. And soon, it was considered to be part of a gentleman's education to know something about gravity, telescopes, and air pumps. They organized very practical demonstrations aimed at debunking popular myths and superstitions. For example, one ancient belief held that spiders could not cross a barrier made from the horn of a unicorn. Lacking a unicorn, powdered rhinoceros horn was placed in a circle, and a spider solemnly placed in the middle. Curiously, the creature crawled out straight away.
Although Cambridge didn't have an active experimental tradition at this time, Isaac Newton realized that you can't just claim universal laws. They have to be subject to observation, rigorous testing, and mathematical proof.
Newton is best known for his work on gravity, But his first great fascination was with another fundamental problem in physics, the nature of light. How, he wondered, could pure white light produce so many colors? Where did they all come from? This question had puzzled scientists for thousands of years. Whilst at university, he began to conduct experiments on himself, sometimes taking things to dangerous extremes. He is said to have stared at the sun until he was forced to lock himself in a darkened room for several days. On another occasion, he forced a large, blunt needle between his eye and its socket to see what effect it would have on his vision. He nearly went blind. But it was with a pair of simple glass prisms that Newton devised his most famous experiment into the phenomenon of light. At the time, people knew that light passing through a prism created a rainbow effect, but most people believed that the shape of the glass somehow tinted the light. What Newton would show was that in fact colour was already present within the light.
Welcome to the laboratory. Today I'm going to be looking at that experiment which Sir Isaac Newton called the wonderful phenomenon of colours. Now, from ancient times, scientists have believed that all light was white because it came from the heavens, and only became coloured by contamination with earthly things. The first scientist to challenge this idea was Robert Hooke, the curator of experiments at the Royal Society. And his researches led him to conclude that light was in two colours, red and blue, and the intermixing of these gave all the colours we have in nature. But Newton was to take these experiments further, and he did this, first of all, by purchasing a pair of prisms at a Cambridge fair. And so it was that with a pair of simple glass prisms, Sir Isaac Newton constructed a highly illuminating experiment.
In his room in Cambridge, Newton allowed a narrow beam of sunlight to pass through his window shutters and enter the prism. This projected a small spectrum of coloured light against the wall. Unlike his contemporaries, Newton felt certain that all of these colours were already present in the white light and were simply being separated by the prism. Using a piece of card with a small hole cut in it, he discovered that if he only allowed one colour from the first prism, for example the red, to pass through the second prism, it was impossible to split it into further hues. The light simply stayed red. In this way, Newton had finally proved that white light was in fact made up of colours that were distinct entities.
It's hard to overstate the revolutionary importance of what Newton said when he claimed that white light was a combination of different colours.
Armed with his knowledge of how light works, Newton set about designing a new kind of telescope. The trouble with traditional telescopes was that imperfections in the glass lenses refracted the light and distorted the image. Newton realized that he could get around this by using mirrors instead of glass lenses.
This therefore led him to make a mirror, concave, curved out in the middle. And this mirror could focus the light just like a lens. And the great beauty of that device was, it was distortion-free.
Newton polished his own metal mirrors, and although his telescope was only 6 inches long, it achieved the same magnification as others that were 6 feet in length.
The success of Newton's telescope provided a brilliant confirmation of his theories of light and colours.
But Newton's work at Cambridge was about to be interrupted.
In 1665, an epidemic of bubonic plague engulfed London. And as there was a fear that it would spread across the whole of England, a quarantine measure was instituted, and all the Cambridge students were sent home.
But his time wasn't wasted. The following year, back home at Woolsthorpe Manor, Newton had his famous encounter with an apple.
And so it was, he found himself on the brink of a discovery that would change the course of science forever.